Hello. Today's lesson is 14-5 and the lesson's called Area and the Distributive Property. Before we move on, I wanted to let people know that we skipped lesson 14-4, which is called Area of Squares and Rectangles. I didn't have the kids do any textbook work on it because I felt like we already understood it. We were reviewing how to find area for squares and rectangles. I just spent a couple minutes talking about it in the next couple slides. So here's one from 14-4. One side of the rectangle, the purple rectangle there, measures 3 feet, the other side measures 2 feet. What is the area and how did you solve? Students knew to multiply 3 times 2, which equals 6, to find the area. We find area by measuring the length times the width of a rectangle. So there it is, the area is 6 square feet, and we talked about how important it is to use that word square when we're talking about area. How about this one? One side of the square measures 8 feet. What's the area and how did you solve? Well, now we only have one number, so what do we multiply that number by? Since it's a square, we multiply 8 times 8. 8 times 8 is 64. The area is 64 square feet. So just to review, a lot of people getting this confused. In the last unit we found perimeter by counting around the edges of a shape. Now we're finding area by counting inside a shape. So remember that important difference. Okay, so now on to lesson 14-5. You've learned that the area of a rectangle is the product of its length times its width. Like we did that problem a minute ago, 3 times 2 equals 6. Today you'll learn how breaking apart rectangles can help you understand the distributive property. So first a question, when you cut a rectangle into smaller pieces, does it change the total area? No, it does not. And students also heard the example of a cookie. If you were given a cookie and before you ate it, you broke it in half, would you still have just as much cookie to eat? Yes, you would. You'd have a broken cookie, but you'd still get just as much cookie. So that's kind of what we're talking about here. The new reading area in the library is shaped like a rectangle that is 8 feet by 9 feet. Mrs. Wallace has a rectangular piece of carpet that is 8 feet by 5 feet for the reading area. On this slide I put in blue the important information and I added a question in purple. So the important information, the reading area is a rectangle that is 8 feet by 9 feet. In my mind, I'm picturing a big rectangle, 8 feet by 9 feet. A rectangular piece of carpet is smaller than that. It's only 8 feet by 5 feet. And then the question, what will the area of the carpeted part be? And what will be the area of the uncarpeted part? The first question is easier to answer because we already know the area of the carpet. We know that the area of the carpet is 8 times 5, or 40 square feet. But how do we find the area of the uncarpeted part? At this point in the PowerPoint, I went to my document camera and we did this as a class, but just to kind of explain it, what we did was we had some grid paper and we started by drawing the big rectangle, 8 feet by 9 feet, and then we drew a line to show the carpet part, 8 feet by 5 feet, and then we figured out from what was left the area of the uncarpeted part, which ends up being 8 feet by 4 feet. Or 8 times 4, which is 32. What do you notice about the sum of the carpeted and uncarpeted parts of the reading area? In other words, I'm going back here to this slide. What do you notice about the numbers 40 plus 32? When I add these up, what do I get? 40 plus 32 is 72. And what is 8 times 9? It's also 72. We know that the sum of the carpeted part and the uncarpeted part add up to the total area of the reading area. These were the kind of problems we were looking at today and they were really confusing for the kids, but I wanted to show them how it works. The first thing we do is we write, write the equation that represents the picture. In other words, looking over there at the big green rectangle, how can we write a number sentence that explains how that big rectangle's been broken into 2 parts? So the big rectangle is 4 units long and 6 units wide. So to find the total area, we start by multiplying 4 times 6. And we know 4 times 6 is 24, but what we're doing first is breaking apart that 4 times 6. So watch how my arrow moves here. Next, instead of saying 4 times 6, we're saying 4 times 6 equals or is the same as 4 times 2 plus 4. Do you see how 2 plus 4 adds up to 6? So saying 4 times 6 equals 4 times 2 plus 4, it's really two ways of saying the same thing. Then we break it up even further. Look at where the arrow goes now. The 2 and the 4 each get multiplied by 4, so this is really what they're calling the distributive property. That 4 that we were multiplying here, we're multiplying it by 2, and we're also multiplying that 4 by 4. So it's 4 times 2 plus 4 plus times 4. Same as 4 times 6. And it really is. 4 times 2 is 8. 4 times 4 is 16. 8 plus 16 adds up to the same as 4 times 6. So that was the kind of thing we were doing today. We looked again at this problem. And that was it for today.